A great next time question after doing IV graphs of a filament lamp is what happens to the current when you turn on a filament lamp? You can see it takes a little bit of time to start giving out the bright light. So what do you think the current time graph will look like for that first little bit of the filament lamp being turned on? To check the answer, I've connected the filament lamp in series with a data logging current sensor, and when I turn on the bulb, that will record a current time graph for me. Let's understand what's going on the current time graph. So we've got a slight zero error, but the current should be zero all the way along here. And then this is the time when it's turned on, and almost immediately, probably limited by the sampling time of the current sensor, the current jumps up to a high value. And that's because the filament is cold. And thinking about the microscopic structure of the filament, the positive metal ions that are fixed in position and can vibrate will be vibrating very little, and so the resistance of the filament when it's cold is small, and hence we get the large current. But as the filament heats up, the positive ions will vibrate faster, so the free electrons are more likely to collide into them, and the resistance increases, and therefore the current drops. And that's what we can see is happening in this section, where the current decreases from its peak and comes to a steady value when the filament of the light bulb has got up to a steady temperature. And that's why filament bulbs were most likely to break when you first turned them on. Let's finish watching one more time as we turn on the filament lamp, and we can imagine the current going very large and then falling down to a steady value as the filament gets hot. I hope you found this video interesting.